Hello, AI enthusiasts. Welcome to a new deep dive. Building on our previous talk about hyperparameters, we now need to know if those settings actually worked. Most videos on evaluation metrics jump straight into confusing formulas. In this video, we want to show something different: the physical intuition of the target scorecard that determines if your model is a master archer or just lucky. Think of your model as an archer. Every prediction is an arrow, and the ground truth is the bullseye. When we train a model, we get thousands of predictions. Looking at them one by one is like trying to judge an archer by watching a single arrow in slow motion. We need a way to summarize the entire performance into a single number. This is where evaluation metrics come in. They are the objective scorecards that tell us how often our arrows hit the mark, and how far they stray when they miss. Without them, we are just guessing in the dark. The most intuitive metric is accuracy. In our archery analogy, accuracy is simply the percentage of arrows that hit the target correctly. If you fire 10 arrows and 7 of them land exactly where they were supposed to, your accuracy is 70%. It is a high-level view of success that answers one simple question: out of all the attempts made, how many were right? It is the first number most people look at, but as we will see, it is not always the full story. To calculate accuracy, we take the number of correct predictions and divide it by the total number of predictions made. Imagine a bucket of all your arrows. We count only the ones that hit the bullseye and compare that to every single arrow you fired. This ratio gives us a decimal between 0 and 1, which we usually express as a percentage. It is straightforward and easy to explain to anyone, making it the most popular metric in machine learning. Sometimes, it is more useful to look at our failures. The error rate is the exact opposite of accuracy. It measures the percentage of arrows that miss the target entirely. If your accuracy is 70%, your error rate is 30%. Think of it as the room for improvements metric. In high-stakes fields like medicine or self-driving cars, researchers often focus on minimizing this error rate. Accuracy and error rate are two sides of the same coin. Together, they always add up to 100% of your predictions. If you imagine a pie chart representing every arrow shot, every slice must be either a hit or a miss. There is no middle ground in basic classification. Visualizing them together helps us realize that reducing our error is identical to increasing our accuracy. But here is what most tutorials never tell you: accuracy can be a liar. Imagine a rigged archery contest where 99 targets are huge and easy to hit, and only one target is tiny and difficult. If an archer simply ignores the tiny target and hits all the easy ones, they would have a 99% accuracy. Does that make them a master? Not necessarily. This is known as class imbalance. Think of a blind archer who always shoots to the left. If all the targets happen to be on the left, his accuracy will be perfect, even though he cannot actually see. In the real world, if you have a data set where 99% of emails are not spam, a model that simply labels everything as not spams will be 99% accurate. But it is completely useless, because it fails to find the 1% of spam we actually care about. This is why we need to look beyond just the raw hit rate. In a spam filter, accuracy tells us how many emails were correctly sorted overall. The error rate tells us how many were misclassified. But as we just learned, we must always ask, what kind of errors are we making? Is the model missing spam, or is it accidentally throwing away important work emails? While accuracy gives us the big picture, the error rate reminds us that there is always a margin of doubt. To wrap up, evaluation metrics are the vital scorecards of machine learning. Accuracy measures our hits, and error rate measures our misses. They are simple, powerful, and essential for understanding if our model is actually improving. However, always remember the lesson of the blind archer: a high score is only meaningful if the game is fair. In our next deep dive, we will explore more advanced metrics like precision and recall to see how we handle those tricky imbalanced targets. Subscribe for more deep dives into evaluation metrics.